Okay, good evening, everyone. Welcome back. To remote folks, can you guys hear me clearly and see my share screen? Thank you. Thank you for your responses. The internet router in this building was updated today, so hopefully we will have a smoother connection. Okay, please quiet down. Are you guys ready for a good class? For remote folks, first of all, please log on Canvas and open quiz 05 for today's lecture. Today, we are going to cover lecture 05. So I want to tell you at the beginning of the class that today's lecture is extremely important and it's a little bit challenging. So I want you guys to pay close attention in the class. And after today's class, you will find out suddenly there are many challenging problems for you guys, okay, in geometry. So the topic today is congruent triangles. So before we give you some theorems about congruent triangles, so let's first have a quick review of congruence. And we learned in the past that figures are congruent if they have exactly the same shape and size. So basically, one is simply an exact copy of the other, of another. Right? For example, so I downloaded this figure is called a minion, right? And then I made a copy of this. So you see two minions. So one is a copy of Lala, and these two minions are congruent. They have exactly the same shape and exactly the same size. And in the past, we defined congruent segments. So two segments are congruent if and only if they have the same length, right? So in this diagram, we have two line segments, AB and CD, in green and in red. So if these two segments have the same length, have the same measure, then they are congruent. Basically, you can move one segment on top of the other, and they match perfectly, right? As you can see here, okay? And also in the past, we defined the congruent angles. So two angles are congruent if and only if they have the same measure. So in this diagram here, angle A and angle B have the same measure, and they are congruent. And you can move angle A on top of angle B such that they match perfectly. So one is a copy of the other. So now we can define congruent triangles. So two triangles are congruent if they have the exact same size and shape, right? So basically, you can move one triangle and put on top of the other such that they can match perfectly. Okay, when you move one triangle on top of the other, you may need to move this triangle, right, in the horizontal direction and in the vertical direction, and maybe you need to rotate the triangle, okay, to put one on top of the other such that they match. So in this diagram here, you see two triangles, triangle ABC in green and the triangle PQR in red. And if these two triangles are congruent, such that you can lay the triangle ABC on top of triangle PQR such that they match. So A now is on P, B is on Q, and the C is on R. So then, obviously, as you can see, so if triangle ABC and triangle PQR are congruent, you know angle A and angle P are corresponding angles because they are congruent. Right? And the angle B and the angle Q are corresponding angles because they are congruent with the same measure. And finally, angle C and the angle R are congruent angles. And also, you know, side AB, which is a line segment, right, corresponds to side PQ, and they are congruent line segments, or say they are congruent sides. They are corresponding sides, okay? And side AC corresponds to side PR in this case, and they are congruent. And finally, side BC corresponds to side QR, and they are congruent with the same measure. So, as you can see, if two triangles are congruent, you can write down all these congruence relationships. Right? You have 6 relationships here because a triangle has has 3 interior angles and 3 sides. Okay, and of course, if we have these 6 congruence relationships, then we can claim these 2 triangles are congruent, right? So this is the definition of the congruency of two triangles. Okay, so in short, you can see it this way. Okay, if two triangles are congruent, then corresponding angles of these two triangles are congruent, and the corresponding sides of these two triangles are congruent. Now, how to write down the congruency of the two triangles? So this is the way you write the congruency, right? So this symbol reads is congruent to. So we have triangle ABC is congruent to triangle PQR. Now I want you to pay attention to the order of vertices in these two triangles. So when I write down this congruence relation, as you can see, right? As you can see, corresponding vertices in both triangles are written in the same order. So in this particular example, triangle ABC is written as in congruence with the triangle PQR. So now you see, right, when we write down triangle ABC, so ABC, these three vertices are in this particular order. Then you know when you write down the triangle PQR in this congruence relationship, so A vertex corresponds to which vertex in this triangle? P. So then you should write down the first vertex in that second triangle as P to be corresponding to A, right? And the second vertex in triangle ABC in this writing here is B. Then the second vertex you write in this second triangle should be what? Should be the corresponding vertex Q, right? So you write down Q. And finally, the last vertex in triangle ABC is C. Then the last vertex in this second triangle should be written as R to be correspondent with C. So ABC in that order, then PQR in that order. Is that clear to you guys? Okay. So you have to, so it's a very important, okay, when you write down congruent triangles, make sure at the two sides of this congruence symbol, okay, the vertices are in the same order. Okay, ABC, PQR. A corresponds to P, B corresponds to Q, and C corresponds to R. So if this writing is correct, then you can easily identify congruent sides and congruent angles. For example, so if this writing is correct, if I ask you which angle in triangle PQR corresponds to triangle correspond to angle A in triangle ABC, then you say, oh, angle P. You agree? And if I ask you which side in triangle PQR corresponds to side BC in triangle ABC, then you say, oh, BC, the last two vertices, then it should be QR. Right? You can easily identify corresponding angles and corresponding sides, okay, with that correct writing over there. Okay. So for example, suppose I write down this congruence relationship. Triangle LMN is congruent to triangle UVW. I even do not need to look at those triangles. I can immediately know angle M corresponds to angle what? Angle V. Do you see that? Because M is the second letter at the left-hand side. Then V is also the second letter at the right-hand side. So M corresponds to V. Vertex M corresponds to vertex V. So that means angle M corresponds to angle V, and they are congruent angles. And if I say which, so, and also you can see side LN should correspond to side UW, right? You see that, right? So you can easily identify congruent sides and congruent angles from these two triangles if this statement is written in the correct way. And when you write down congruence of two triangles, you need to write down your congruence in the correct way, okay? Now, I want you guys to do a quick practice here. So now I have two quadrilaterals two quadrilaterals. Quadrilaterals means a geometric figure with 4 sides. Now you see, right? 4 sides. Okay. So I state that LMMP is congruent to FGHE. Okay. Pay attention to this statement. Okay, this congruence statement. Okay. Then based on that congruence, what's the value of X? So obviously in this case, so if this congruence statement is written correctly, we know vortex L corresponds to vortex F, right? Vortex L in this red quadrilateral corresponds to vortex F in this green quadrilateral, and so on and so forth. And so in order to find the value of X, we know 2x degrees are the measure of this angle E. And this angle E corresponds to which angle in this red quadrilateral? So if you see here, that E corresponds to letter P, right? So corresponds to this angle here. So then we know angle E and angle P, they must be corresponding angles, they must be congruent. Okay, they must be congruent. So they have the same what? By definition of congruence of angles, they have the same measure. So 2x degrees would be the same as 70 degrees. So immediately 2x equals 70. So x should be 35, right? 35. Okay. Is that clear to you guys? So in this case, right, according to this writing here, angle L corresponds to angle F, angle M corresponds to angle G. And in this case, I sketched these two figures, right? I sketched these two figures in the same orientation. Somehow you can easily see corresponding vertices. But sometimes, okay, sometimes I may rotate one a little bit, right? Then you have to be careful over there. Right? You can notice, say, for example, if I rotate this guy such that this E is at this location now, and then F is at that location, right? And G is at this location, then H is at this location. I can rotate this whole thing. Do you agree? Then you should say, okay, now L, according to this writing here, L corresponds to not E now, corresponds to what? To this F. Do you agree? Right? So if the figure is rotated, you should be able to, again, identify corresponding angles and corresponding sides using that statement. Okay. Problem number 2. So I tell you quadrilaterals LMMP is congruent to FGHE. Can you write the congruence in this way? MMPL is congruent to EFGH? Yes or no? So the answer is yes or no?
No.
No, right? No. So this is the statement of the congruency. Okay. And this is the right statement. That means L corresponds to F. But if you read this second statement here, L now is corresponding to H. And obviously that's not right. Right? M should correspond to G, but here M corresponds to E in this second statement. So this second statement is a wrong way to write down the congruency. Okay? So you cannot do so because you messed up the correspondence. Okay, you messed up the correspondence. Okay, of the vertices in these two congruent figures. Okay. So the answer is no. Okay, remember that. So I emphasize this. Okay, so you should be careful when you write down congruence. Now, let's consider this problem here. So in this problem here, you see a lot of triangles, right? You see a lot of triangles. And obviously, you can tell by the marks on this figure that side AB, or this line segment AB, is congruent to which one? To AC, right? So triangle ABC is called an isosceles triangle because two sides of this triangle are congruent, okay? And also you can see AD, this segment is congruent to AE, right? You see? By the congruence marks, okay, you can see that. And what else? And you see BD is congruent to EC, yes, to EC, right? Both segments are marked with a one dash, okay, so they are congruent. And can you see some congruent angles? Angle B is congruent to which angle? Angle C, right? Angle ADE, let me call this angle 1, okay? Angle ADE is congruent to angle AED, right? These two guys are congruent, okay? And finally, these two angles, angle BAD is congruent to angle EAC, right? So this diagram, okay, shows a lot of congruence relationships, okay, without words, okay? So we just use marks, okay, to indicate congruence. Now I ask you, okay, think about it, okay? Can you figure out the answer to this question here? Triangle ABE, okay, read, okay, ABE. This triangle here, right? Is this triangle congruent to ADC, ABE, and ADC? This triangle here.
Yeah.
And if they are congruent, how are you going to write down the congruence relation? First of all, why they are congruent?
Same size and same
Same size, same size, and same shape. Okay, but you need to show that, right? You need to show. Okay, they have the same. So here is the, so probably you guys you see, right? So AB is one side of ABE. So let me use the green color to draw this triangle here. Triangle ABE. This triangle, okay, triangle ABE. The other triangle is triangle ADC. Let me use green color, red color for that triangle. ADC. This triangle. Okay, so let's check. AB is congruent to AC, right? So that's known. And so, and AE is a side in that green guy, right? Is congruent to AD, which is a side in the red triangle, right? We have two pairs of congruent sides. Now, how about this third side in ABE? So the third side in ABE is BE. Is BE congruent to CD? Let me ask you another question here. And why? Do you think BE is congruent to, right? B is this side here, right? In triangle AB. And the DC is the other side in triangle, in the red triangle, right? Yes or no?
Yes.
Why?
EA is BD plus DE.
And
DC is CE plus DE.
yeah, that's the reason.
And if you take away DE from both, you get the congruent relation.
Yeah.
Statement.
Okay, so BE, okay, BE is the sum of, so the length of B is the sum, is a BD plus DE. Right, plus DE. And DC is the sum of EC plus DE, right, or CE plus DED. Right, or say EE plus EC. Right, and we know BD and the EC are congruent, right? So these two guys match. Oh, sorry, EC. And the DE is common to both, right? So obviously, then we know BE has the same measure as DC, so they are congruent. I should write down literally. Okay, they're congruent. So now you see the three sides of a triangle ABE are congruent to the three sides of a triangle ADC, right? So all the sides of one triangle are congruent to all the sides of the other triangle. Now let's check angles. Angle B, this is the angle in green triangle, right? Congruent to angle what? Angle C in this red triangle, okay? That's one pair of congruent angles from these two triangles. And how about the angle E, angle 2 here? Angle 2 is an angle in that green triangle, is congruent to angle 1 in the red triangle, right? Now we have a second pair of congruent angles. Do you agree? Now, how about the third pair? Is angle BAE congruent to angle CAD, right? BAE is this third angle in this green triangle, and CAD is the third angle in that red triangle. Do you think this last pair of angles are congruent? Yes or no? So, do you think this angle is congruent to this angle? You see that? Yes or no? Yes, why? Because triangle BAE, the measure of triangle BAE is the measure of angle 3 plus this middle angle. The measure of this middle angle, right? And the triangle CAD, the measure of triangle CAD is angle 3 plus the measure of angle 3 plus the measure of this middle angle, right? These two angles are congruent, and this one is common. So of course, these two guys are congruent. Do you see that? So the answer to this problem is also yes, right? So is this true? The answer is also yes, because BAE is the sum of angle 3 and let me call this angle 4. How about that? The middle angle. So it's angle 3 plus angle 4, right? Angle 3 plus angle 4. Now, how about the angle CAD? It's also the sum of angle 3 and angle 4, because these two guys, we know they are congruent, right? So it's also the sum of angle 3 plus angle 4. So of course they are congruent. Now you see all the three angles of that green triangle are congruent to all the three angles of that red triangle, right? Red triangle. So now we know these two triangles must be congruent. So we have checked all the congruency relations. And how to write down the congruency? And you guys try to figure it out. Suppose I write down triangle ABE at the left-hand side of the congruence relation, right? So triangle ABE, this green triangle, is congruent to that red triangle. How should you write down the red triangle at the right-hand side? A corresponds to which vertex in ADC? ABE, ABE. Then should be A. So A corresponds to A, right? Do you see that? This angle, right? 3 plus 4, 3 plus 4, they share the same what? The vertex, right? So A corresponds to A. Then B corresponds to which one? C, yes, right? Angle B is congruent to angle C. So, and the next letter should be C. And finally, E corresponds to what? To D, right? See, angle 2 is for letter E, and angle 1 is for letter D, right? 1 and 2, they are congruent. Yes. Okay, sure. So that's the right way to write down the congruence. Okay, to write down the congruence. Does that make sense to you guys? Okay, good. So you need to match vertices of corresponding angles. Okay. So now, as you can see, in this case, in order to show that these two triangles are congruent, I have shown all the three angles of one triangle are congruent to all the three angles of the other triangle. I also have shown all the three sides of the one triangle are congruent to all the three sides of the other triangle. So that's a lot of work, right? Because I have to show 6 congruence relationships. I need to establish 6 congruence relationships. That's very time consuming, okay? So do we really need to show all these congruence to prove the two triangles are congruent? So how much information do we need to test the congruence? Okay, so let's first of all answer this question here. So suppose triangle ABC and the triangle PQR, these two triangles satisfy these two relations. Angle A is congruent to angle P. Okay, let me mark the congruence on the figure, on the diagram for you guys, okay? And angle B is congruent to angle Q. Now, what you can say about the angle C and the angle R? And why? Are they congruent? Or they are not congruent? Or you cannot tell? So I know 2 angles of this green triangle are congruent to 2 corresponding angles in that red triangle. I want you to draw a conclusion about the third angle in this green triangle and the third angle in that red triangle. Do you think those third angles are congruent? The answer is yes or no.
Yes.
Some said yes, some said no. Why they are congruent?
Because angle C and angle R are all one.
Yeah. What do you say, Andrew? Yeah. Harry, do you agree? Do you think they are congruent? Yes, right? Because the 3 interior angles of a triangle add up to 180 degrees. So if measure A is equal to measure P, measure B is equal to measure Q, then the third one is 180 minus these 2 measures, right? So they should be the same. Do you agree? So this angle C, the measure is 180 degrees, subtract measure of angle A and the measure of angle B. From now on, just say minus angle B and angle B, okay? Minus angle C. And this one, angle R is 180 degrees minus angle P minus angle Q, right? But A is the same as P, B is the same as Q, right? Angle B, A is angle A is measure is the same as angle P, and angle B measure is the same as angle Q. So of course, the third angle, angle C, has the same measure as the third angle, angle R, right? So they are congruent. So the answer is yes. So what does that tell you? So in order to prove 2 triangles are congruent, do I need to show all 3 angles are congruent of one triangle to the other? We just need to show 2, right? If I can show 2 of angles in one triangle are congruent to 2 angles of the other, I don't have to show the third one, because automatically the third angle of the first one triangle should be congruent to the third angle of the other triangle. Okay, so you don't need to show all these 6 congruence relationships to prove congruence of 2 triangles. Yeah, this problem is irrelevant to lengths. Yes, it's about angles. So obviously, do we have to explicitly show congruence of all pairs of corresponding angles and sides to test the congruence? No, right? No. From this whole question here, obviously, we don't have to do so. And actually, we can use less information, okay? So now, let's consider this case. Okay? So consider triangle ABC and PQR. Consider triangle ABC and PQR. Okay, so if we know angle A is congruent to angle P, okay, so look at this diagram here. Okay, angle A is congruent to angle P, and also I tell you AB is congruent to PQ. They have the same measure. Okay, so obviously now suppose I only know these two pieces of information. Okay, I know these two congruence relationships. Yes, yeah, okay. So angle A is congruent to angle P, and AB is congruent to PQ. Can you claim that these two triangles are congruent? But now I have so less information, okay? The answer is no. Can you see, right? I can draw two triangles. ABC, this red triangle, see? AB matches PQ. Angle A matches angle P, but obviously in this figure here, triangle ABC is not congruent to triangle PQR, right? Because I can make that AC shorter than P and the PR because we don't know anything about these two sides, AC and PR, right? So you can draw these two triangles to satisfy the given information. Do you see that? Right? See, angle A matches angle P. Move here to there, right? Match. And angle, side AB matches side PQ. Now I can put C here and put R there, right? And I can have two triangles, triangle ABC and PQR, and they are not congruent. So obviously, in this case, we cannot claim that two triangles are congruent with these two congruence relations. Okay, so somehow, in order to prove the congruence of two triangles, you need to have sufficient information, but you don't have to show the congruence of all pairs of congruence of angles, and you don't have to show the congruence of all pairs of angles and all pairs of sides. Okay, that's too much. But if the information is not enough, again, you cannot achieve that. So what you can say here? So obviously, we have to think about, right, how much information is needed, okay, such that we don't do extra work. We can still prove the congruence of two triangles. So soon we are going to have quite some theorems, okay, and each theorem gives us necessary and sufficient condition for the congruence of two triangles. So let me launch this problem number 4. Okay, and so again in problem number 4 we have two triangles, and I give you two congruence relationships. Can you use these two relationships to claim that the two triangles are congruent? Okay, consider triangle ABC and PQR. AB equals PQ, AC equals PR. Can we claim that ABC and PQR must be congruent? Must be congruent? You can try to draw, okay? This, then see if you can draw two different triangles that are not congruent to satisfy these two relationships. If you can draw two different triangles to satisfy these two relationships, then this claim cannot be true, right? So how to answer this question here? You can do this experiment here. So triangle ABC has how many sides? 3 sides. Okay, one side is AB. Right? Triangle PQR also has 3 sides. One side is PQ, and the AB equals PQ. So basically, we can use. So basically, I tell you, one side of AB is congruent to one side of PQ of triangle ABC is congruent to one side of triangle PQR, and the other side AC of triangle ABC is congruent to PR of the other triangle. So basically, so somehow you are given 2 sides of a triangle. And so basically, you can think this is a construction problem. Can you use 2 sides to determine a unique triangle? So the answer is what? The answer is no. Right? The answer is no. Think this way. Right? So AB equals PQ equals S1. So somehow you have a fixed length. And you're going to use that one length to be the length of one side of a triangle. Then you have another length, which is S2. You can think you have 2 sticks. Okay, you have 2 sticks. Okay, so first of all, you treat one stick as AB, the other stick as AC. Do you agree? So you can make triangles, use these 2 sticks. And in the second case, you can treat one stick as PQ, the other side as PR. Still, because they have the same size. So think really is like can you use 2 sticks to make just one unique triangle? The answer, of course, is no. Right? When you have 2 sticks with a fixed length, suppose this length is S1, that length is S2. You can just change the opening, right? The angle between these 2 sticks to make a lot of different triangles. Do you see that? Right? We agree? So you can think this way, right? So look at this diagram here. Say this is S1. That's the length of AB or PQ. Okay, then you have S2. That's the length of AC or PR. So you can think this point here is A, and this point is B, and this point here is C. Or you can treat this point also as a point P. This point then is Q, and this point here is R. Do you see that? So you have A, B, C, or P, Q, R. Now, as you can see, right? So AB is congruent to PQ because we use the same stick for these 2 sides. And AC is concurrent to what? To PR, right? I use the same stick for that side, right? Now, obviously, you can make 2 different triangles, right? Such that ABC is different from PQR. You see that? So ABC, you can move this C around this circle here, right? So keep that distance the same. Now you can make infinite many triangles. Can you see that? Infinite triangles. You see, you can make this triangle here like this shape, right? This guy triangle, ABC. Or you can move this C to this location, or say R into this location, right? So C can be here, or maybe say maybe call it R. You can move this R to this location here, right? So maybe I call this C, I call this R. You see that? So say AB is congruent to PQ, AC is congruent to PR, right? Because they are the radius of this same circle. But obviously, triangle ABC is not congruent to triangle PQR, right? PQR, because with only 2 fixed sides, you can make infinite many triangles. Okay, you can make infinite many triangles. So you cannot claim those triangles are congruent. Okay, so you miss some information to have the congruency. Okay. So finally, so how much information do we really need, right, to claim congruence? Right. So if I have 2 sides congruent to the other two sides of 2 triangles, we cannot claim congruency. Okay. One side and one angle of one triangle are congruent to one side and one angle of another triangle. Again, we cannot claim congruency. Okay, we did these 2 questions. So how much information do we need? So now we are going to introduce a few very, very important congruence postulates. Okay, basically that they are theorems. Okay, but we're not going to prove in this class. Okay, I think I'm going to make sense for these guys. So let's do this way. Suppose I give you 3 sticks. Okay, so you can use 3 pens if you want, right? And their lengths are fixed. Okay, so how many triangles? How many different triangles you can make with these 3 sticks? With the same shape and the same size? Only one, right? So if of course if these 3 sticks can make a triangle by connecting all these end points, right? So let's see, I have 2 sticks, you connect these 2 ends. Then you have to open this angle such that you can fit this 3rd stick to connect the 2 ends of the 3rd stick to the other 2 ends of these 2 sticks to make a triangle. You can make a unique triangle with these 3 sticks. Do you agree? Right? Pardon me?
Can you just change the color?
What do you need to change?
The chainsaw. And then just cut one of the sticks out.
Okay, I tell you, you use just given 3 sticks, right?
Oh.
So yeah, you have 3 fixed sticks, right? So with the 3 sticks, and if you can make if you can enclose a triangle, that triangle is fixed, is unique, okay, with the same shape and same size. Okay, we can think this way, right? Suppose I give the 3 lenses ABC, right? 3 lenses ABC. So you put the C, right? You put C here, right? You draw a segment AB such that its length is C. Then you can use a compass and use the length B as the radius to draw an arc. So in this case, you see, I use this compass and use B as a radius. I draw this red arc. Then I use length A as the radius, but this time my fixed length is at B. I draw another arc, right? The green arc, such that these 2 arcs they intersect. Then you can get a triangle with these 3 lenses, right? ABC, right? This length is B by that compass, and this length is A, and this is given C. Okay. So let's question I already asked you, right? Experiment. Use 3 pencils to make a triangle. Can you make 2 non-congruent triangles with different shapes or sizes by doing this way? The answer is what? Is no. You can only make 1 unique triangle if you can make a triangle.
Wait, the pencils are the same size, right? They are the same.
Not necessarily of the same size. Just 3 sticks with different lenses, but you need to make sure these 3 sticks can enclose a triangle. And if 1 stick is too long, like 2 other 2 sticks are too short, you cannot make a triangle. Do you agree? Yeah. So the answer to this problem is no. Okay, you cannot make different triangles with different shapes and different sizes. But keep in mind, I think you answered that question, right? If 1 pencil is much longer than the other 2, then a triangle cannot be made. Can you imagine that? Right? Suppose you have this very long stick, you have 2 very short sticks, right? You cannot read. Yeah, then the 2 ends of the short stick cannot be put together, right? Because the 3rd stick is too long. That's something we're going to learn later. It's called the so-called triangle inequality. Okay, more about this later. So based on the experiment we just did, now I think you should be able to understand this congruence postulate. It's called SSS congruence postulate. So if the 3 sides of 1 triangle are congruent to the 3 sides of the other triangle, what you can say about these 2 triangles? They're congruent, right? Because basically it's just like so you use 3 sticks to make 1 triangle. You use the 3 same sticks to make another triangle. Do you agree? Because all the 3 sides of this triangle are congruent to all the 3 sides of that triangle. Basically, you use the 3 same sticks, right, to make 2 triangles. Of course, these 2 triangles must be of the same shape and the same size. We just did that experiment. Does it make sense to you guys? So that's the claim of this SSS congruence postulate. Why is it called SSS? Because it's side, right? Side of one triangle are congruent to side of another triangle, right? 3 sides congruent to 3 sides. Got it? So it's called, we use the first letter of the side, okay, S. So we indicate this congruence as S congruence. Is that clear to you guys? So that's our first congruence postulate, S congruence postulate. Let me just address. Let me just answer this question quickly here, okay? Okay. So in this diagram here, right, we say AB is congruent to PQ. That means we use that same stick, right, with the same length. So we can make that AB, we can make that PQ. Do you agree? Then we have BC congruent to QR. Then we have the second stick, right, to make BC or make that QR. And lastly, the third stick AC, the third stick makes AC and QR. So we can use these 3 sticks to make a triangle ABC and PQR. Obviously, we know these 2 triangles must be congruent. Okay. So now let me show you an example how to use this S congruence to prove triangles are congruent. Okay, look at this example here. Given triangle ABC as an isosceles triangle with base BC. If BC is the base, that means AB and AC are 2 what? Called 2 legs, and they are congruent. Okay, so let me mark these 2 legs, okay, as congruent legs. Now I want you to prove angle B is congruent to angle C. I want to prove the congruence of these 2 base angles. And this is a fact later on you have to remember. Okay, when you have an isosceles triangle, so the two base angles must be congruent. Okay, the 2 legs are congruent. Yes, you have a question?
Right.
Okay, now how to prove this? First of all, suppose you have a problem like that, you need to draw a good diagram. So suppose someone want to prove that fact, right? So, oh, I have an isosceles triangle. So someone did like this. I'm going to draw an isosceles triangle with my hand. Oh, this triangle. Oh. Oops. Let me turn off this. Right? And say, oh, I have a triangle ABC. Is that a good idea to do the problem? No, right? So you have to draw, as I said, as I recommended in the first class, draw a nice diagram. And when you have a nice diagram, it can help you solve the problem. Okay, you cannot do like this. You say, oh, AB is congruent. Well, obviously, AB is not congruent. They are not straight at all, right? This is a bad idea to do that. So you want to, first of all, you draw a good diagram. So you have an isosceles triangle. You say, okay. So we draw an isosceles triangle. So this is one leg. This is the other leg, such that they are congruent. And this is my base, like this. Okay. So you can mark the congruence like this. Okay, so we have a triangle ABC, and AB is congruent to AC, or say AB and AC have the same measure. Okay, so I want to prove what? Angle B is congruent to angle C. They have the same measure. So how to do this proof here? It's very hard at the beginning, so I can give you one way to do this proof here. Okay, let me give you a hint. So what I'm going to do, I'm going to find the middle point of BC. I call it M. So M is the middle point. Okay, so if M, so you can, given a segment, you can always find the middle point of that segment, right? You can do so. Okay, so suppose M is the middle point. If M is the middle point, what you can claim? Then BM and CM, they must have the same what? same length, same measure. Do you agree? Like that. Then what I'm going to do, I'm going to draw an auxiliary segment. So I'm going to connect A and M. So this is called an auxiliary segment because it's not there in your original problem, right? I just add that, right? So I find the middle point, I connect A and the middle point. Now, you guys look at this diagram and see if we can find a way to prove angle B is congruent to angle C using congruent triangles. Which two triangles are congruent and why? Can you see? If you have drawn a very good diagram, probably you can somehow guess, right? Oh, this triangle must be somehow looks like a congruent to another triangle, right? Then you can try to test if that's the case. So which two triangles do you think are congruent? ABM and ACM. No, okay, so that's your speculation, right? Your speculation. You have to somehow what? Give evidence, okay? You have to prove. Now you try. So what kind of information you can get for this problem? AC. So if they are congruent, then B angle is corresponding to angle C. Then you can prove angle B is congruent to angle C. You can prove the problem. Do you agree? Because if these two triangles are congruent, you can claim angle B is congruent to angle C if they are corresponding angles, right? So that's a good approach. Now, how can you prove angle ABM and the angle ACM, they are congruent? Right now, we only learned one congruence postulate, which is called what? SSS. Can you use SSS as a postulate to prove these two triangles are congruent?
Yeah.
Yes. How to do that? AB congruent to AC. AM equals AM is shared, right? Is shared by the two triangles. So AM is the side of that triangle, is the side of the other triangle. So shared, of course, they're a side is congruent to itself. You agree? So AM is congruent to itself. And how about BM and CM? Yeah, by my construction, right? I use M as the middle point, so they're congruent. So finally, you can use the SSS postulate to prove this triangle, this half triangle is congruent to that half triangle. Then you can claim angle B and angle C are congruent. Okay, so that's the proof. So the key to this proof here is what? Is to draw that auxiliary segment. Right? Otherwise, you don't know how to do it, right? You have one triangle there. How can you see B and C are congruent? Angle B, angle C are congruent with that two sides. You cannot do that. You somehow have to make two triangles to prove this. Okay. So let me write down the full proof for this problem here. Okay. So here is the proof. So first of all, okay. So let M be the midpoint of the base BC. Then what we're going to do? We draw the segment AM. Okay, draw the segment AM. So we have this diagram. Okay, I already did that on that diagram. Okay, now you can construct a two-column proof. So now you say, okay, so we have statements and the reasons. Guys, please pay attention. Okay, so first of all, I can claim AB is congruent to AC. So AB equals AC. What's the reason for that? Because the triangle is isosceles, right? So that's the given condition. So given condition, because isosceles. Isosceles triangle. Okay. And by construction, BM equals MC. BM equals CM. Right? BM equals CM. Why? Because M is the middle point by definition. So definition of a middle point. And finally, AM is shared, right? AM is the side shared by both triangles. So AM equals AM. You can say this is the so-called AM equals AM, right? So it's called a reflexive identity property, right? Property. Right? Now you can claim because of the three sides of a triangle ABM, so AB corresponds to AC, AM corresponds to AM, BM corresponds to CM. So then you can claim these two triangles must be congruent. So you can say, oh, triangle ABM. Triangle ABM, which is this triangle here, right? Triangle ABM is congruent to triangle. Congruent to triangle. This right triangle here, this guy, ACM. How to write down this triangle? A corresponds to which one? AB corresponds to AC. So this is the way to write down this. Okay, you see? AB corresponds to AC. So we have AB here, right? Then this part here should be either AC or CA, right? Only two ways to write down. Do you agree? Such that AB corresponds. So you can try this. You should say, okay, maybe I can write down AC here, or maybe I can also write down CA because AB corresponds to AC or CA. That's the same thing. Okay, you have two options. Now what's the next? Then how to which one is correct? You say, okay, next BM corresponds to which one? BM corresponds to CM. So the last letter must be M now. Do you agree? Right? We already used two letters. Then you see which one is correct. BM should correspond to what? To CM. But if you write down this one is AM, that's wrong. Do you agree? So which one is correct? So this guy is correct. This is wrong. So then you see the right way to write down is of this triangle should be like this, right? ACM. And you can check, see AB corresponds to AC, AB AC. BM, CM, BM, CM. And then finally, AM, AM. See that, right? So all the three corresponding sides of one triangle are congruent to the corresponding sides of the other triangle. And what's the reason for this congruence? You can write down what? What's the reason for that? It's called a SSS. Okay, congruence postulate. You just write down SSS. That's good enough. See? This is how many lines? 1, 2, 3, 4, 4-line proof. Okay, a 4-line proof. That's it. Okay, not bad, right? Not bad. Okay. Let's take a 8-minute break. Okay, we resume the class at 8:10. Okay, 8:10. Any questions from you guys? Okay, to remote folks, we are about to resume the class. If you hear me, please come back and raise your hands to let me know you're ready. We are about to resume the class. To remote folks, please come back and raise your hands. Thank you. Remote folks, the last call, please come back and raise your hands. We are about to resume the class very soon. Thank you. Okay, you can lower your hands. So let's consider one more example to use the SSS congruence postulate. Then I'm going to ask you guys to do a poll question. Then we move on to the other postulates about the congruence of triangles. So let's consider this problem here. So we have a pentagon shaped like this, okay? By the way, this is the building Pentagon, right, in Washington. Have you visited the Pentagon? Okay, so we can use the middle point of this pentagon to divide this pentagon into 5 triangles. Pentagon means a figure with 5 sides. Penta means 5. Okay, so we have 5 sides: A, B, B, C, C, D, D, A, B, A, E, right? 5 sides around. Okay, and we can divide this pentagon into 5 triangles like this way. Suppose I tell you these 5 triangles. I source these triangles. I source these triangles such that their bases are the 5 sides of this pentagon. Okay, so A, B, B, C, C, D, D, E, A. So those are the 5 sides of this pentagon. They are also the basis of these 5 isosceles triangles. And I also tell you the basis of the 5 triangles are congruent. So in this diagram here, now you can see that AB is congruent to BC, to CD, to DE, to AE, because those guys are the basis of the 5 triangles. Now I want you to prove the measure of each of these 5 angles is 72 degrees. So angle 1, angle 2, angle 3, angle 4, angle 5, they have the same measure. And the measure of each angle is 72 degrees. So how to prove that? So obviously, if I can prove these 5 angles are congruent, then they have the same measure. And then you know the sum of their measures, the sum of the measures of these 5 angles should be what? Should be 360 degrees, right? So because these 5 angles make the full revolution, okay, make the full angle 360 degrees. So then if they are congruent, then the measure of each angle is simply 360 degrees divided by 5, which is 72 degrees, right? So all you need to do is prove these 5 angles are congruent. Then you can compute the measure of each, okay? So how to prove these 5 angles are congruent? And keep in mind, these 5 small triangles are isosceles triangles with those guys as their legs, right? So for example, if you look at this triangle here, then these 2 sides are the 2 legs, and AB is the base. And similarly for this guy, for this guy, for this guy. Can you see this now? So what's your hypothesis here? If you take 2 triangles out of these 5 triangles, what do you think these 2 triangles must satisfy which relation? So let's take out 2 triangles. For example, let's consider triangle ABO and the BCO. I want to prove angle 1 and angle 2 are congruent angles, right? So by your good sketching here, you can speculate that these two triangles must be what triangles? Must be, they are congruent triangles. They must be congruent triangles. Can you prove that? So consider triangle triangle OAB and triangle OBC are two arbitrary triangles, right? Out of these 5 triangles. If I can prove they are congruent, then I can prove all these 5 triangles must be congruent. We agree? Because I just take 2 of them, right? And you can do the similar thing for any other 2 triangles. And then by the transitive property. So this triangle is congruent to the second triangle is congruent to the third triangle, and so on and so forth. So all these 5 triangles must be congruent. Now you can claim these 5 angles are congruent angles. How can you prove triangle ABO and triangle BCO, they are congruent triangles? You can use what? S postulate. You agree? Because I know. So let's consider OAB. So you see, is OA equals OB? Yes, because the triangle is isosceles, right? Isosceles triangle. So OA equals OB. But OA is a side of this triangle, and OB is a side of the other triangle. Now you see, how about the OB and the OC? Is OB equals OC? Again, yes, right? Because this triangle is also isosceles. Right? And finally, is AB equals BC? That's the given condition, right? Because all the bases are congruent, right? So these are 2 bases, AB and BC. So now let's see. Triangle OAB is congruent to triangle, which triangle? This triangle here is congruent to this triangle, right? How to write down this second triangle? OA corresponds to what? OAOB, right? So this should be OB, right? OAOB, they are corresponding sides. Then OB corresponds to OC, right? OBOC. So OBOC. And finally, AB corresponds to BC. You agree? So this is due to SSS congruency, right? SSS congruency. So now what you can claim? You can claim angle 1 and angle 2 are congruent. So measure of angle 1 equals measure of angle 2. And then you can write down, similarly, you can prove angle 2 is congruent to angle 3, right? Angle 3 is congruent to angle 4, right? You just take the other 2 neighbors, right, to do the same thing. Do you agree? So then you just simply say, similarly, then you can say angle 2 is equal to angle 3, angle 3 is equal to angle 4, and angle 4 is equal to angle 5. Do you agree? So then you can use these 2 guys, this pair or this pair, or that pair, right? Doesn't matter. We apply the same argument. Okay. So then you can claim all these 5 angles are congruent. So angle 1 equals angle 2 by the transitive property equals angle 3 equals angle 4 equals angle 5. That means their measures are the same. And also we know the sum of these 5 angles is 360 degrees, right? These 5 angles make a 360-degree angle, right? Like this. So the measure of each would be, 360 degrees divided by 5, which is 72 degrees. So that's the proof. Okay, that's the proof. Is that clear to you guys? That's good. Now you guys try this one. Problem number 6. Okay, AB is congruent to DC. Okay, AE is congruent to DE, and DE is congruent to CE. Now, how about this triangle? Triangle ABC is a big triangle, and the other big triangle DCB. Do you think they are congruent or non-congruent, or you need more information to determine if they are congruent or not? when you choose your answer, you should have a reason for that, okay? In another word, you can prove your conclusion. And in today's homework, you are going to construct a lot of proofs. The dog has the answer. Do you understand what he? Okay. Do you think they are congruent? Yes or no?
Yes.
Why? Because of
ABC is ABE plus DEC and DBC is DEC plus.
okay, yes, right. You need to use a you use the given congruency conditions, then you can figure out AC is congruent to BD. Right? Why AC is congruent to BD? So let me mark these two guys. AC is congruent to BD. So they are corresponding sides. AB is congruent to CD. That's given, right? That's given. BC is what? Is common to both, right? It's shared. So BC is congruent to BC itself, right? And finally, the third side of ABC is AC. The third side of this triangle is BD. Are they congruent? Yes, because AC is the sum of AE and EC. And BD is the sum of DE and BE, right? AE congruent to DE. So these two guys have the same length. And these two guys have the same length. Then the sums are the same, right? So the answer should be A. Okay, the answer should be A. So here is the proof, right? So first of all, so you know, okay, so let me. So I want you, I mean, you figure out the answer. I want you to write down your proof, okay, in a very neat and organized manner, okay? So if I write down the proof for this problem here, you do like this, right? You write down a two-column proof. So statements and the reasons. Michael, can you move your seat to here? Can you sit here? Okay. Come here, sit here. Otherwise, you guys somehow cannot focus because you guys know each other and talk with each other. Okay, so first of all, we know AB is a side in this triangle. Yeah, you can see it here or there, either way, yeah. Right? So AB is a side of this triangle ABC, right? Which is AB is congruent to DC, so they have the same measure, right? DC. And DC is the side in triangle BCD, okay? And secondly, BC is equal to BC itself, right? BC is the side shared by both triangles, right? So we already have two pairs of congruent sides, okay? And lastly, then we need to figure out if side AC is congruent side BD, right? This green side and the red side if they are congruent. But we know AC, we know AE equals DE, that's given, right? And DE equals CE, right? So these two guys are given conditions. And this is also given. This is basically a reflexive property. Right? So then you can claim what? Then you say AB plus B, AE plus EC. So you add these two guys, AE plus CE, right? You see, so AE plus EC, or say CE if you want, must be same as what? Must be same as DE plus BE, right? So DE plus BE, okay? Plus BE. And we know AE plus CE now is AC. So you have AC equals DE plus BE, as you can see, DE plus BE is BD. So finally, we have SSS, right? SSS. So by SSS congruency, we can claim triangle ABC is congruent to triangle. How to write down the second triangle? If I write down ABC, then D what?
CB. No,
DCB, yeah, DCB, okay, DCB. Why? I hope you when you get confused, right? Or hopefully, in this case, somehow you see AB corresponds to DC, this corresponds to that, and this BC is short. So BC is short. So AB, you see, AB corresponds to what? According to your statement, is DC, right? AB equals DC. Now you should write down DC or CD, right? So you have another way to write down, okay? Either write down DC or CD. Then the last letter should be B, right? So it's either DCB or CDB. Then you use the other pair to figure out the right writing. So then you see BC corresponds to what? To BC itself. But this is DB. So you should use this one, right? You see that? So then we know this is the correct writing and this is wrong, right? This is wrong. Okay, so you can do that. Okay, so let's move on to our second congruence postulate, which is named SAS congruence postulate. So before I introduce this congruence postulate, let me do a construction problem. Suppose, okay, I give you one side of a triangle and another side of the triangle, and also I give you the angle between these two sides. Can you use the given two sides and the angle between to construct a triangle? And how many different triangles you can construct with two given sides and the fixed angle between the two sides? The answer is just one. Okay, how to do that? So you can do this. So basically, you just say, okay, I'm going to draw an angle. That's the given angle, right? The given angle between the two sides. Got it? So I draw that angle with that given measure. That angle is fixed. Then I can take this length on one side. That's the given side. I take the length of the other side. Then I can find the other side. Then obviously you can connect these 2 points, right? So AB is given one side, AC is another given side. Then B and C are fixed. You can draw BC to finish that triangle. You see that? So this case, we have the so-called SAS construction. And pay attention that A means what? Yeah, means angle. And A is between S and S. So A is an angle between two given sides. Okay, so pay attention to the order of these 3 letters. It matters, okay? The order matters. So it's S side, then S another side, and A is between the 2 sides. Got it? Okay, so the SAS, A is between. It's called included angle, okay? So A is included between the 2 sides. So SAS is different from, I have a better word here, ASS, right? What is ASS? That is, we have a, so this is the SAS, you see? A is between 2 given sides. But ASS is, you give an angle, then you have this side, then this side is opposite to that angle, right? Do you see that? That's a SS, A is not between. Do you see that? So then it's called ASS when you read it in this way, okay? And we do not have ASS congruence. Just keep that in mind. ASS is a better word. We don't have that congruency, okay? We don't have that postulate, okay? So now, okay, to understand this SAS congruence, can you do this experiment? Problem number 7. Extend, okay, you do this, okay? Extend the 2 fingers, right? So each finger is like one side with the fixed lenses, right? Do you agree? Then you form a fixed angle with these 2 fingers. Then you connect the 2 tips of the 2 fingers to form a triangle. So how many different triangles can you form with these two fingers and add a fixed angle between the two fingers. Obviously, how many? Just the one triangle. You can only do one. Can make one triangle, right? You can only make one triangle. So the answer should be A. Okay. Very good. So the answer is A. So this tells you what? So if you are given two fixed sides and you fix the angle between the two sides, you can always make just one triangle. So if you have two triangles, suppose you have two triangles, so the two sides of one triangle are congruent to the two sides of the other triangle, and the angle between the two sides in the first triangle is congruent to the angle between the two sides in the second triangle. Then these two triangles must be the same triangle. Do you agree? So they must be congruent. So that's the so-called SAS, congruence postulate. Got it? Right? You can just always think about this picture here, right? SAS, S, A in between, right? One triangle. If you make another triangle here, there, they are congruent, right? Same triangle, right? S, A, right? All congruent. So this is the statement of the SAS congruence postulate. So look at this diagram here, right? AB is congruent to PQ, and AC is congruent to PR, and angle A is congruent to angle P, and angle A and angle P are included angles, right? Then you can claim what? These two triangles are congruent. Basically, you just use the two fingers and fix the angle to make two triangles over there, right? Like that, right? Make a copy over there. Do you agree? So we have the so-called SAS congruence postulate. Now, how to use this congruence postulate? So this time, right, I want to do this problem again. I have an isosceles triangle with base BC. I want to prove that two base angles, angle B and angle C, are congruent. This time, I want you to use SAS congruence postulate. Can you do that? Think about it. Again, we need to use auxiliary lines or auxiliary segments, okay? How to draw an auxiliary line to finish this proof, okay? I want you to prove angle B and angle C are congruent by SAS congruence postulate. So how to do that? Yes. Yeah. Any idea how to do this? So in this case, AB is congruent to AC. Okay, BC is the base. I want to prove these two angles are congruent. Okay, I want to prove that. Right now, I don't know if they're congruent or not, but I want to prove they are congruent. So how to do that? How to use SAS? Previously, we used SSS. To use SSS, I use midpoint. Then I know SSS, right? But now I need to use SAS. So the trick here is draw an auxiliary segment like this. And this guy is called an angle bisector now. Angle bisector. So I draw an angle bisector AD of angle BAC, such that this angle bisector intersects BC at D. Got it? So now I have this. Now can you see why these two triangles are congruent? Do you have SAS?
Oh.
Yes or no? AB is congruent to what? AC. AD is shared, right? It's shared by two triangles. And this angle and that angle, they are congruent by my construction because the angle bisector. So basically, you have two fingers, right? The middle finger is shared by both triangles, and the angle is fixed, right? You can put here, then rotate that, put there, to make two congruent triangles. Do you agree? Like this way. So I think you get the idea now, right? So how to prove this? So first of all, what I'm going to do, I'm going to draw the angle bisector of angle BAC, right? This angle here. There are angle bisector of ABC. Okay, and such that it intersects BC at D. So that angle bisector is simply AD now, right? AD. Now I can finish the proof using SAS congruence postulate. So I have a two-column proof. The first column, in the first column, I write down statements. In the second column, I write down reasons for those statements. Okay. So first of all, let me write down obvious facts. Okay. So we know AB equals AC. Because the triangle is isosceles, right? Isosceles triangle ABC. Okay, we know AB equals AC. Secondly, AD is shared by both triangles ABD and ACD, right? So you can write down AD equals AD. That's kind of an obvious fact. You don't have to write down reason for that if you don't want. Okay, that's okay. AD equals AD, of course, that's obvious. It's called reflexive property. And finally, by my construction, right, we know angle BAD equals angle CAD, right? Angle BAD equals angle CAD. Why? Because AD is the angle bisector, right? Angle bisector. AD, because of that angle bisector. Now what do you have here? We have S, and A between, right? See, S, see, can you write down like this? S, A, S. Of this triangle are congruent to S, A, S of that triangle, right? You can apply SAS congruence postulate. So you can make a claim now. You say triangle, so you write down reason here. The reason is SAS congruence. Right? So the first triangle is triangle ABD, right? Triangle ABD. Congruent to which triangle? To that right side triangle, right? This triangle, right? This triangle. But how to write down that triangle? Yeah, it should be ACD. Because AB is congruent to AC. So the first two letters should be AC or CA. But then you figure out AD equals AD. So then you should be, so the third letter is D, then A should be the first letter, right? AD. Do you see that? See? AB corresponds to AC. Then AD corresponds to AD. And finally, BD corresponds to CD, right? As you can see, like that. Okay. We're not done yet. So then you can make a claim. So finally, because these two triangles are congruent, so we can claim, so angle B, right, which is right here, right? This angle should be congruent to this angle here, angle C, right? Angle B is congruent to angle C. This is the definition of congruence, right? The definition due to congruence. Congruence property of C. Okay, so that's the proof. So it's like a 1, 2, 3, 4, 5 line proof, right? It's kind of a short, but it's not that easy because you have to figure out a way to make congruent triangles such that you can draw the conclusion. And how to make congruent triangles? In this case, we somehow divide this big triangle into two smaller triangles, two smaller congruent triangles using the angle bisector. So then I can use SAS congruence. And previously I proved the same problem, but we draw the.
Did you shoot FaceTime video?
Sorry for that. So previously we proved the same problem, but we draw the auxiliary line by connecting A and the middle point of DC.
Did you shoot FaceTime
Right?
video?
Remember that? Okay. Okay, good. Now let's move on to this problem here. Given AC equals CD, BC equals BC equals CE. Can you prove AB must be equal to DE? How to prove that? Do you see the strategy here? By your observation, do you think which two do you think which two triangles are congruent? Which two triangles look congruent? ABC and EDC. Do you agree? So then it's just a matter to prove them they are congruent. If they are congruent, then you can claim AB is equal to DE if they are corresponding size, right? If they are corresponding size. So that's your strategy, okay? So you do have some information, right, given here, right? So you have some congruence relationships among these two triangles. You see, AC is congruent to CD, right? AC is a side of this triangle here. So let me shade this triangle here, ABC. Right? See? Then we have another triangle here. Let me shade with a different color here, this triangle here. So these two triangles seem to be congruent. And also we know AC congruent to CD, EC congruent to BC. Then you ask yourself, can you use SSS congruence to prove they are congruent?
Yeah.
Can you? No, because the problem asks you to prove AB equals DE, right? You cannot use that condition here. I don't know if AB is equal to DE now, right? It's something I need to prove. So you cannot use SSS. And now, can you use SAS?
Yes.
Yes. So why you can use SAS? What do you think these two angles are congruent? Yeah, they are called vertical angles. Then you're done. Do you see that? So you use SAS. See, like two fingers and the opening between two fingers, like that, right? Make that triangle and make that triangle, right? Like that. Got it? SAS. So can you write down a proof now? Yes, right? So you can do like this, okay? So first of all, you write down obvious things. You say AC equals DC, given. We have one pair of S, right? SS, okay? S to S, given. And also we know BC equals EC, right? BC equals EC. This is also given. Then you can use vertical angles. You say angle ACB has the same measure as the angle DCE. The reason here is vertical angles. Then you can claim these two triangles, triangle ABC is congruent to triangle, this lower triangle. How to write down this lower triangle? ABC. If I write down the first triangle as ABC, how should you write down the second triangle? AB correspond to which side? DE. DE or ED, right? So you have two ways, DE or ED. But which way is right? Then the last letter should be C, right? So which one is right? Yeah, ABC should be DEC. Why? Because you see, because BC corresponds to what? To CE. So it should be this guy, right? This, then if you write down this way, then it's DC. So this is wrong. Do you agree? So you write down as an angle triangle DEC. Okay, triangle DEC. This is due to SAS congruence. Okay, and then finally, because these two triangles are congruent, then you can claim AB side corresponds to which side? AB side corresponds to DE side, right? According to this writing here. So then you can claim AB is congruent to DE with the same measure. That's due to the congruence. Congruent triangles, congruency property of the triangle. Okay, so we have finished the proof, right? We have proved AB is equal to DE now. So these two sides are congruent. Now, how about problem number 8? Yes, true or false problem, okay? if two legs of a right triangle are congruent to two legs of a second right triangle, do you think these two right triangles must be congruent? Draw your picture here. Two legs. What are the two legs of a right triangle? Are the two sides adjacent to that right triangle? So yeah, you can use of course you can use SS, use the Pythagorean theorem. Okay, that's good. But we have not learned the Pythagorean yet, so we can use the SAS, right? So the answer should be true or false? True, right? You see, you have a right triangle here, right? You have a right triangle. Then this angle is the right angle at minus 90 degrees. Then we know this side is congruent to this side. Suppose we have another right triangle here. Okay, and this leg, right? And this leg is congruent to that leg. This is also right. So obviously, you see you have SAS, right? You can use the SAS congruence postulate to prove these two triangles must be congruent. Do you agree? Okay, so the answer is true. The answer is true. Okay, by SAS. So how many congruence postulates we have learned so far? SSS and SAS. Now, in the last 15 minutes or so, we are going to learn ASA and AAS congruence. So first of all, we have the so-called the third angle theory. So given two triangles, say triangle ABC and the triangle PQR. Suppose I tell you angle A is congruent to angle P and angle B is congruent to angle Q, then the third angle of triangle ABC, which is angle C, must be congruent to the third angle of triangle PQR, which is angle R. I think we already proved this before, right? So you remember that, right? Because the three interior angles of any triangle add up to 180 degrees, right? So then you know these two guys must be congruent. Okay, congruent. So basically, if I know two angles of one triangle are congruent to two angles of the other triangle, then I can claim all the three angles of the first triangle are congruent to all the three angles of the second triangle. Do you agree? Right? AA means AAA. The double A means triple A, right? Because two of them are the same, then the third one should be the same too, right? So AA is equivalent to triple A. Okay, triple A. Remember that fact. So basically, in when you have the so-called ASA or AAS postulate, so you have two angles of one triangle are congruent to angles of the other triangle. Then basically, it's simply it's a triple A plus S. Okay, right? Three angles of one triangle are congruent to the corresponding three angles in the other triangle. Okay, then you also have a side of one triangle is congruent to the side of the other triangle. So it's a triple A plus S. But a triple A plus S can be split into two scenarios. One is ASA, the other is AAS. They are different. Okay, let me show you. So what is ASA? Where is the letter S? S is between two A's. So in this case, look at this picture here. We have a triangle ABC and a triangle PQR, right? So angle A congruent to angle P, angle B congruent to angle Q. So we have A, right? So these two angles are congruent to these two angles. So AA, we have A and A. Okay. Now when we consider ASA congruence, so that S, that side is between what? Between the two angles. Okay, that's the so-called ASA case. Can you imagine that? So you can use the construction to make sense of this. Suppose I give you a length, a side. Okay. Now I'm going to draw two fixed angles. We draw one angle And you draw another, this is a fixed angle, okay? And you draw another fixed angle. And you make how many triangles? You can only make one unique triangle, right? So one unique triangle with the same shape and the same size. That's why we have a so-called ASA congruence postulate. Got it? The other one is called AAS. What is AAS? AAS is like this, right? So again, angle A congruent to angle P, angle B congruent to angle Q. Now that side S is this side, for example, AC or P. AC is congruent to PR. So you have angle, right? This angle. But the side is opposite to one angle here now. So it's AAS, right? AAS, right? When you read this in this order, you know this S now is not between these two angles. It's opposite to that first angle, first A. So you can write down as like a A1, A2S, right? This is A1, this is A2, then you have S, right? A1, A2S. That's one scenario. Or maybe you have A2, A1S, then you have BC congruent to QR case. Okay, you have two situations. So we first of all, we know angle A congruent to angle P, angle B congruent to angle Q. Now, how to prove these two triangles are congruent? If I know AC is congruent to PR, then we have so-called A1, A2S case. A1, A2S case, AAS. Okay, then we can claim these two triangles are congruent. Or you are given, instead of AC congruent to PQ or PR, you are given BC congruent to QR, BC congruent to QR. Then you can read this as A2, A1S, right? A2, A1S. Right? Again, that's the AAS case. Do you agree? So pay attention to the position of that S. That S may be between two two angles, or maybe it's opposite to one particular angle, right? Either this A1 or maybe opposite to that A2. Okay, AA. But in either case, we have AAS. Okay. So again, this problem one more time. Given, this is different now. Okay, so given a triangle ABC, I tell you angle B and angle C are congruent. Now I want you to prove this triangle is isosceles. AB equals AC. How to prove that? There are many ways. Okay, many ways to do this proof. But I want you to prove this fact or this conclusion using let me see, AAS congruence postulate. AAS congruence postulate. So how to do that? Let me give you a hint. First of all, I know so I need to somehow draw an auxiliary line to cut this triangle into two smaller congruent triangles, such that AB and AC are corresponding sides. Then I can prove AB equals AC. Okay. So in the past, we draw an angle bisector. We draw a segment connecting A and the middle point, right? So depending on the way you construct this auxiliary line, you have different congruence. You need to apply different congruence postulates. So in this case, suppose I want you to apply AAS. The way to do that, let me give you a hint. I'm going to draw again. Draw this auxiliary line. Let me call it AD. So if I want to use AAS, what do you think that this AD should be? I have A here, right? A, right? A corresponds. This A is congruent that A, right? I have one A now. Do you have S? AD is shared by both, right? We do have S, right? We have one S, right? AD is equal to AD, right? AD is shared by two triangles. Now, if I want to use AAS, so this is one A, S, or maybe AAS. Which way? So you can either construct AD as an angle bisector. Then you have angle side. Angle side. Do you see that? You can apply AAS. Or if I want to use AAS, if I read this way, so AAS, then what should be AD now? If I instead of angle bisector. Now I need to make sure these two angles are congruent, right? Now what is this line here? If these two angles are congruent, what are their measures? 90 degrees. So what are the AD is called? It's not angle bisector. Now it's called a perpendicular line. You draw a perpendicular line perpendicular to BC such that this line is through that D, right? You can do both ways. Then you can apply AAS. Okay. So I think I ask you. So in my notes, I said draw the angle bisector. If I do the angle bisector, then I do the AAS, right? Use AAS. Okay. But I'm going to do a different manner now. So what I'm going to do, I'm going to delete this. So I'm going to say, oh, I'm going to draw AD such that this AD is perpendicular to BC. Is that okay? That's okay, right? So I can do a different manner. Okay, so I'm going to do this proof. First of all, I make this auxiliary line, draw AD such that AD is perpendicular to that BC side. Okay, and the perpendicular, this D is called the perpendicular foot, right? So AD intersects BC at D. Okay, AD and AD intersects BC at a point D. Okay, so basically that D is right here. Now I have two triangles. These two triangles are two right triangles now. Do you agree? Right triangles. So we can construct this two-column proof. Okay, statements and the reasons. Okay, so first of all, let's write down obvious facts. Okay, given information. So first of all, we know angle B is congruent to angle C. That's a given condition. Okay. Secondly, AD is shared by these two triangles, right? AD equals AD. That's an obvious fact. I don't have to write down reason for that. Okay. And finally, angle BDA equals angle CDA, right? Both are equal to 90 degrees. So angle BDA equals angle AD. Let me erase this confusing stuff over there, right? Then angle BDA equals angle CDA equals 90 degrees, because by the construction, AD is a perpendicular is a perpendicular line to BC, right? This is by construction. So now we have, see, AAS. Do you see that AAS, right? AAS, right? AAS. So by AAS postulate, so we can claim triangle ABD is congruent to triangle. How to write down? If I write down the first triangle as triangle ABD, then what's the second triangle? How to write down the second triangle? ACD, right? I think it's kind of obvious from this picture here, right? ACD. Okay, you can double check that. Okay, I did this multiple times, so I'm going to save some time. So it's ACD. This is by what? By what postulate? AAS, right? AAS. And keep in mind that this S is opposite to this angle, right? These angles. So then you can claim what? You can claim AB equals AC, right? Corresponding sides, right? Say AB is this side, must be congruent to that side. So you can say AB equals AC. So that's the full proof. Okay, full proof. So before you leave, I want you guys to try this last poll question here. Okay, AB is parallel to DE. AC equals CE. Okay, let me mark that for you. Okay, AC equals CE. Do you think these two triangles, ABC and DEC, are congruent? And if yes, why? You need to prove. You need to be able to prove it. Okay, not just guess. Oh, by my eyeballs, or they look congruent. That's not the right argument in geometry. Okay. So what's your answer? Yes or no?
Yeah.
What the congruence postulate? AA plus, in particular, is in this case the AAS or ASA. Either way, right? You see, right? You see, first of all, this angle is congruent to that angle. These two lines are congruent, parallel. So, okay, so you see, ASA. Or you can do this congruent to that, then is AAS, right? So the answer is yes. Okay, that's all for today's class.